Hello and welcome back to the good stuff that we have been doing. In the previous video, we derived the general formula for the integral representation of the polylogarithms, and we did say that the polylogarithm of a of x is equal to -1 to the a minus 1 all divided by gamma of a times the integral from 0 to 1 of x log t all divided by 1 minus xt dt, whereby in this our case we have the dilogarithm. So basically the dilogarithm of x would be equals to, here a would be 2, so you would have -1 of negative times the integral from 0 to 1 of x log t all divided by 1 minus xt dt. So this will be the integral representation of the dilogarithm. And also, if we have a trilogarithm here, we'll be using the integral representation of the trilogarithm, but here now we have a dilogarithm, and then the task now is to solve this beautiful integral. And here's how we're going to proceed. Just like in the previous video where we substituted for this dilogarithm, you're going to replace the logarithm by this. So you're going to have the integral from 0 to 1 of log x times dilogarithm of x all divided by 1 plus x dx. This is going to equal the integral from 0 to 1 of log x all divided by 1 plus x. Then you multiply this by negative times integral from 0 to 1 of x log t all divided by 1 minus xt dt, then dx. So now we have on the left hand side our original integral. Now on the right hand side we have a double integral, and which may seem counterintuitive, but sometimes in mathematics, to actually simplify, you need to complicate a bit. So let's trust that our complication will lead us to the right path. So essentially this would equal, you have a negative times integral from 0 to 1 times integral from 0 to 1 of x log x, then you have log t all divided by what? 1 plus x, then you have a 1 minus xt dt dx. Now what we have is that, forget the log terms. Observe that here you have an algebraic term here, x, 1 plus x, and then 1 minus xt, and we can put this in partial fraction, and this would be 1 over 1 plus t. Then on this side you have a 1 minus xt, and on this side you have a 1 plus x. And observe here that if you add this term inside a bracket together, you should get 1 plus x on one part, so you get a 1 plus x on this side, and you subtract 1 plus xt, and you're dividing by 1 plus x and then 1 minus xt. So here the ones cancel out, so you have an x, 1 plus t all divided by 1 plus x and then 1 minus xt. So you see that all the terms on this side, you see that all of these terms, they cancel out, so the partial fraction actually works. So basically we would have to just write this as negative times the integral from 0 to 1. Now then the integral from 0 to 1. Now instead of everything here, you have a log x log t all divided by, you have a 1 plus t, and then you have a 1 minus xt, so you have 1 plus t and 1 minus xt, and then you have minus the minus log x, log t all divided by, you will have a 1 plus x, 1 plus t, and then you have a 1 plus x here, dx dt, right? Dx dt. Now since we are actually integrating dx first before dt, we can factor out all the terms concerning just t's alone, and that will lead us to say negative times integral from 0 to 1. You have a log t all divided by 1 plus t. So we are integrating with respect to x first, so anything concerning t should be just kept outside first. So you have the integral from 0 to 1 of log x all divided by 1 minus xt, then you have minus the integral from dx, of course, dx, the integral from 0 to 1 of log x all divided by 1 plus x dx, and then everything here dt. So you can see that slowly but surely everything is simplifying neatly, because we now have two integrals to worry about. This first one, let's call it I1, and this second one, let's call it I2. And let's see whether we can do something with I1 and I2 differently. Now let's demarcate this first, and let's change some color for pen. Now returning to I1, notice that if you use the integral representation we derived, I1 is clear. I1 would be equals to negative dilogarithm of x over x. Sorry, dilogarithm of 2 over t. Let's go back and see. You can see we said dilogarithm of x is the integral from 0 to 1 of x log t over 1 minus xt. So now if you come back to I1 and observe that you have the only term missing here is the t terms. So basically I1 is okay, it's not going to be in terms of x, it's going to be in terms of t rather. Okay, so I1 here would be negative dilogarithm of t over t. So what about I2? How do we evaluate I2? Well, I2 is not too hard to evaluate. You just to evaluate I2, the integral from 0 to 1 of log x all divided by 1 plus x is going to first of all be the integral from 0 to 1. It's going to be equal to the integral from 0 to 1 of log x. Then 1 over 1 plus x, you can write this as the sum as n runs from 0 to infinity of, as n runs from 1 to infinity of negative 1 to the n minus 1. Then you have x to the n minus 1 and dx. So everything here would become factor out the sum. So you have the sum as n runs from 1 to infinity of negative 1 to the n minus 1. Then you have the integral from 0 to 1 of x to the n minus 1 log x dx. And this integral would not be too hard to compute even, because here all you need to do is to observe that you could change this to be the sum as n runs from 1 to infinity of negative 1 to the n minus 1 times the partial derivative with respect to n of the integral from 0 to 1 of x to the n minus 1 dx. So now if you take this integral and take the partial derivative, you have a negative 1 over n squared. So you have this is negative times the sum as n runs from 1 to infinity of negative 1 to the n minus 1 all divided by n to the second power. And this is going to be equals to, okay, so this would equal negative pi squared over 12, or over 12, which is negative 1 over 2 zeta of 2, because zeta of 2 is pi squared over 6. So now we have for I1 and I2, so we could write this as to equal the negative times integral from 0 to 1 of log t divided by 1 plus t. Then for I1 you have negative dilogarithm of t over t. Then for I2 you have negative times negative 1 over 2 zeta of 2, and all of them would be dt. So whereby when all is said and done, you would have the integral from 0 to 1 of log t times dilogarithm of t. Then you have a t and 1 plus t, and then on this side here you have minus the integral from 0 to 1 of log t times zeta of 2 all divided by 2 1 plus t dt of course. Then next here now we can proceed, and then we're going to do the bottom part in partial fraction here, because I think 1 over t 1 plus t should be 1 over t minus 1 over 1 plus t, because if you add them up here, so you will have this to be the integral from 0 to 1 of, you have log t, the logarithm of t, all divided by t dt, and then minus the integral from 0 to 1 of log t, then you have the logarithm of t, all divided by 1 plus t dt, and on this side here you have minus zeta of 2 times the integral from 0 to 1, all divided log t, all divided by 1 plus t dt. And I think now we have three integrals, but they are not really that troublesome, because the middle one is basically I, but the first one here can be done with integration by part, because we could write the first one to be the integral from 0 to 1 of log t times the derivative of the trilogarithm of x prime dt, sorry, trilogarithm of t prime dt. Now the middle one is basically I, which is our original integral. Then the third one is basically going to be negative 1 over 2 zeta of 2. Now of course we know this is equals to negative 1 over 2 as well, zeta of 2, because this is identical to our original integral. Recall what we did here. We computed this integral here and we got everything to be negative 1 over 2 zeta of 2, so it's identical to that integral, which saves our work. Now we would have this to be, if we do integration by parts here, you will have this to be integral from 0 to 1 of the trilogarithm of t all divided by t dt. Then you have minus I, then you have plus 1 over 4 zeta squared of 2. Now we can push I to the left and divide everything by 2, so that leaves you with, this is equals to 1 over 2 times the integral from 0 to 1 of the tetralogarithm of t prime, because if you take the derivative of the tetralogarithm of t, you have trilogarithm of t over t, so prime dt, then plus 1 over 8 zeta squared of 2, and then this would be just 1 over 2 times the tetralogarithm of 1 plus 1 over 8 zeta squared of 2. Now tetralogarithm of 1 is clear. This is equals to the sum as n runs from 1 to infinity of 1 over n to the 4th power, and this is basically equals to pi to the 4 over 90, and this is, I think this will be 2 over 5 zeta squared of 2 over 5 zeta squared of 2, right? Because this will be 2 over 5 times 1 over 36 pi to the 4th. Yes, because 36, let me check my calculator and see. So just hold on. So 2 over 5 times 1 over 36, 5 times 18, 2 divided by 5 times 1 divided by 36. So yes, so that is 2 over 5 zeta squared of 2. So you have 1 over 4 times 2 over 5 zeta squared of 2 plus 1 over 8 zeta squared of 2. Now let's add 2 over 5, 1 over 10 and 1 over 8. So you have 1 divided by 10 plus 1 over 8. So you have 9 over 40. So I have 9 over 40 zeta squared of 2. Okay, let's see, is that the answer we started off with? Okay, we're having 3 over 40 here. That means there must be a little bit of arithmetical error. Let me check. Okay, so the mistake here is that instead of 1 over 2, I wrote 1 over 4, so we should have 1 over 2 here. and 1 over 2 here. So that should give us and also because of integration by part step, we should have a negative here. So at the end of the day, we should have a negative 1 over 5 zeta squared of 2 plus 1 over 8 zeta squared of 2, which is negative 3 over 40 zeta squared of 2. So that is that. Now that corresponds to the correct answer. So thank you very much for watching, and please do enjoy your day. Bye.